In this video presentation, we're going to look at the cable that comes in to the bottom of the cutout. So it's the cable down here, it's black. It's often confused to be a steel wire armoured cable. However, we're going to see in this presentation that it isn't, and it's actually a concentric cable. We're also going to cut back to the classroom where I can actually show you how it would be connected within the cutout itself. Obviously I can't dismantle this one at a domestic dwelling in order to show you those connections, but I can back in the classroom. But while we're here, we're also going to reiterate some of the equipment we've got here at the intake position of this domestic dwelling. So if I bring the camera in nice and close, let's have a look at what equipment we've got here before we go back to the classroom. So this cable here is the one that's often mistaken coming into the bottom as a steel wire armoured because of its look being black and physical construction. It looks like an armoured cable. It isn't, and we'll see in the classroom what's happening with the conductors inside this cutout arrangement, an arrangement which is TNCS, terra, neutral, combined and then separated. So the line conductor comes into the fuse. The fuse can be rated at either 60, 80 or 100 amps. And then we have this combined conductor, the combined neutral and earth, TN, terra neutral combined in this concentric cable coming in, separated in the installation. 16mm earthing conductor going into the consumer unit, 25mm squared neutral conductor going into the kilowatt hour meter. We'll be able to see when we get back to the classroom what's actually happening inside here and the construction of this cable, as I've got one set up ready to show you. Let's just reiterate a few other points while we're here. The kilowatt hour meter, we've got a 100 amp double pole isolator here, so we could turn off the consumer unit the other side and work on it safely. Obviously we'd have to secure the isolation, etc. Remembering you cannot pull this fuse, it's already sealed in place. You have to get permission in order to pull that fuse out. And also our meter itself is also sealed, so we can't access the terminations in here. So if at any point you needed to access these, you need to gain permission, and often permission won't be granted. They'd come out and actually pull the fuse for you on your behalf. We haven't got that issue here because we can actually turn our consumer unit off with this isolator just here. So let's cut back to the classroom now where we can have a closer look at this cable here and see how it would be connected inside a cutout. So I've got my mimicked rig here. I've got my mimic cutout fuse, remembering the three sizes are 100, 80 and 60 amps for a domestic dwelling. We've got our 25mm squared meter tails going into our kilowatt hour meter, slightly different than the ones we've seen before. And this is our earthing conductor going out, and it's mimicking a TNCS earthing arrangement. It's the cable coming into the bottom that we're concentrating on, trying to work out what it's doing and what it is. It's one of these. It looks like that coming into the bottom like so. So it looks like that. Often mistaken for a steel wire armoured cable because of its colour of being black and physically looking similar to a steel wire armoured cable. However, when I turn it round, you can see that that isn't a steel wire armoured cable, and we've got only two conductors. A centre conductor insulated in brown to denote that it's a line conductor, and has a silvery looking conductor there. That's aluminium, that's our line conductor. And the outer, which we think is armouring, is actually our neutral and earth, our protective earth neutral. So we've got a combined conductor here. This is a concentric cable. This isn't steel wire armoured. It looks like a steel wire armoured cable until you strip it back. It's a concentric cable, a cable that has a combined neutral and earth and line conductor, in this case with an aluminium material. Copper, neutral earth, aluminium for the line conductor. Let's have a look inside here and see how that's going to be connected. Okay, on this demonstration rig, I will be allowed to pull this fuse. Under normal circumstances, you wouldn't be allowed to pull it, and it's sealed either top and bottom or in one position in order to prevent you from pulling that fuse. In the event of requiring to pull that fuse, you need to contact your DNO in order to be given permission. For me, it's not a problem. I can pull out this fuse, a fuse that wouldn't be pulled out under load conditions. If you look there, this one's rated at 100 amps. You wouldn't want to pull that out with it drawing 100 amps. It could create a massive arc across here, and that wouldn't be safe. But for mimicking purposes, that's not an issue. Let's pull it out. Let's have a look at how we're going to terminate the conductors under here. So I undo this screw here, a screw you'd never normally get access to. And I pull that to one side, and I just lift this out of the way, like so. And if we reintroduce our conductor now, like that, okay, you can see that the line conductor would be going into the bottom of the fuse. The fuse would either be 100, 80 or 60 and go out, in this case, on our 25mm squared double insulated metering tails. And the combined neutral and earth conductor would be connected into here, where we have both the neutral going out and the 16mm earthing conductor going out. So you can see that if we go back to our original TNCS, Terra, neutral are combined on the supply authority side, so a combined earth neutral on the supply authority side, and then in the installation you have a separate neutral and a separate protective conductor, TNCS. The Terra neutral are combined on the supply authority side and separate within the installation itself. You can see in here that we would connect our conductor in from the bottom and go out with a neutral and our earthing conductor, and we say for exam purposes these are connected via a solid link. In other words, in this one solid connection here you have both the neutral and the protective conductor. So let's reiterate the connections in the bottom of the kilowatt hour meter. Our incoming line and neutral from the supply authority side go line and neutral. The tails that would be connected this side are the ones that go into the installation to the consumer unit within the dwelling, and they go out neutral and line. So let's look at that again. So line, neutral in, neutral line going out into the dwelling, and obviously we take in the 16mm protective conductor as well. So our earthing conductor goes into the installation as well. So hopefully that's taken some of the myth away about the cable coming into the bottom of a cutout looking like a steel or armoured, but actually being a concentric cable. However, there are other styles of concentric cables. So if I get the next one out, it's going to obviously look a little bit different, not only from colour, but obviously from construction as well. This is what's known as a split concentric cable. This can be used for a TNS earthing arrangement. As before, we've got an insulated aluminium conductor for our line conductor. Now what we saw before was the copper, which looked like armour in, which was our combined neutral earth on our original pen conductor, is now been insulated for a number of conductors in blue, because they will be your neutral, away from the bare ones that will be your protective conductor. So this is a split concentric cable. So I hope this video has added a little bit more detail. It's looked at the incoming cable not being a steel or armoured, but being a concentric cable. And I hope this video has been some help.